Have you ever looked up at the night sky and wondered just how big the universe really is? The answer is almost impossible to imagine. The observable universe stretches about 93 billion light-years across, and that's only the part we can actually see. Beyond that, it may continue forever. Inside are trillions of galaxies, each filled with billions of stars, planets, and mysteries we still don't fully understand. Our entire planet is just a tiny speck in one ordinary galaxy called the Milky Way. In the next few moments, we're going to journey from Earth to the edge of the known universe and discover how unbelievably massive reality truly is. Today we will talk about how big is the universe actually? So before we start, make sure to hit the like button and subscribe to my channel. 1. Understanding what size even means in cosmology. When we ask how big the universe actually is, we are really asking a question that does not have a simple edge-based answer. In everyday life, size means the distance between boundaries, like the length of a room or the diameter of Earth. But the universe may not have a boundary at all. Instead, cosmologists define a practical limit called the observable universe, which is the region from which light has had time to reach us since the beginning of cosmic history. This observable region is about 93 billion light-years across, meaning that if we draw a sphere centered on Earth, its diameter stretches to that unimaginable scale. However, this is not the full universe, only the portion we can see. The actual universe may extend far beyond this limit, possibly infinitely, meaning that what we observe is just a small cosmic bubble inside a much larger or even endless structure of space. 2. The age of the universe and why distance is misleading. The universe is estimated to be about 13.8 billion years old, a value determined through precise measurements of cosmic microwave, background radiation, and the rate of cosmic expansion. At first glance, one might assume that the observable universe should therefore have a radius of 13.8 billion light-years. However, this is a misunderstanding caused by the dynamic nature of space. While light travels toward us, space itself is expanding, stretching distances in the meantime. As a result, the farthest observable regions today are not 13.8 billion light-years away, but roughly 46.5 billion light-years away in all directions. This means that the light we see from distant galaxies started its journey when those galaxies were much closer, but by the time the light reaches us, the fabric of space has expanded enormously. This effect shows that the universe is not static. It is continuously growing, and distance in cosmology is deeply tied to time and expansion. History rather than simple linear measurement. 3. The origin of everything. Expansion from the Big Bang. The expansion of the universe originates from the event known as the Big Bang. This was not an explosion into empty space, but rather the rapid expansion of space itself from an extremely hot, dense initial state. In the earliest moments, all matter, energy, space, and even time were compressed into an extremely small, nearly uniform state. As expansion began, the universe cooled, allowing fundamental particles to form, followed by atoms, stars, galaxies, and large-scale structures. Importantly, the Big Bang did not occur at a single location in space. Instead, it occurred everywhere at once because space itself was the thing expanding. Every region of the universe was once much closer together, meaning that the entire cosmos shares a common origin point in time, even though there is no spatial center to the expansion today. 4. Inflation. The universe's extreme growth spurt. One of the most important ideas in modern cosmology is cosmic inflation. Inflation refers to a brief period immediately after the Big Bang, when the universe expanded at an exponential rate, growing far faster than the speed of light, which is allowed because it is space itself expanding, not objects moving through space. During this tiny fraction of a second, the universe increased in size by an enormous factor, stretching microscopic quantum fluctuations into large-scale structures that later became galaxies and clusters. Inflation helps explain why the universe appears so uniform. In all directions, even regions that seem too far apart to have ever exchanged information. It also strongly suggests that the universe beyond what we can observe is vastly larger than our cosmic horizon, potentially extending far beyond any conceivable measurement. 5. The structure of the observable universe. Within the observable universe, matter is organized into a vast and intricate cosmic web. Galaxies are not randomly distributed, but instead form clusters, superclusters, and long filament-like structures separated by enormous voids where very little matter exists. Current estimates suggest there are roughly 2 trillion galaxies within the observable universe, each containing anywhere from millions to trillions of stars. These galaxies span distances of millions to billions of light years, forming some of the largest known structures in existence. Despite this enormous complexity, when viewed on the largest scales, the universe appears surprisingly uniform, meaning that matter is evenly distributed when averaged over very large distances. This large-scale uniformity is a key assumption in cosmology and allows scientists to model the universe using relatively simple physical laws. 6. Cosmic horizons and the limits of what we can ever see. The universe has natural observational limits known as cosmic horizons. One of the most important is the particle horizon, which defines the maximum distance from which light has had time to reach us since the beginning of the universe. Beyond this lies regions that are currently unobservable. Even more restrictive is the event horizon, which defines regions of space from which light emitted now will never reach us in the future due to the accelerating expansion of the universe. This means that some galaxies we can currently observe are already becoming unreachable, not because they disappeared, but because space between us is expanding too quickly. Over time, more regions will cross this horizon, gradually shrinking the portion of the universe that future observers will be able to see, even though the universe itself continues to expand. 7. What lies beyond the observable universe? The true size of the entire universe remains unknown and is one of the deepest questions in cosmology. There are 2 main possibilities. The first is that the universe is finite but extremely large, possibly many hundreds or thousands of times bigger than the observable region. The second is that it is infinite, extending without end in all directions. If the universe is infinite, then the observable universe is just a tiny sample of an endless cosmic expanse. If it is finite, it still must be vastly larger than what we can observe because of inflation and the limits of light travel. Since no signal from beyond the observable horizon can ever reach us, direct measurement of the full universe is impossible in principle, not just in practice. 8. The human meaning of an immensely large or infinite cosmos. The scale of the universe fundamentally changes how we understand our place within it. Even within the observable universe, distances are so vast that light takes billions of years to cross them, and yet this region may still be only a fraction of reality. The universe is not only large in spatial terms, but also dynamic, constantly expanding and evolving over time. Every second, space stretches further, increasing the separation between distant galaxies and potentially pushing some regions beyond observational reach. Whether the universe is finite or infinite, its scale far exceeds human intuition and everyday experience. But if you like this video and would like to see more like it, please give the thumbs up, leave a comment, and click the button to subscribe.